Hello everyone, thanks for joining us today. I'm Srinivas Kesanapalli, Senior Partner Solution Architect in Data and Analytics.
And my name is Danielle Greshak. I'm a Senior Manager in Solution Architecture in the AWS Partner Program. And we're going to talk to you today about building and automating a modern serverless data lake on AWS. So first and foremost, why AWS for data and analytics? So as you know, we are the most agile, scalable, and we have the broadest and deepest set of capabilities. Our platform is low cost, and we also allow you to get insights faster. And really one thing we've focused on, especially in the last few years, is making data migrations easy. If any of you maybe used some products like import-export a couple of years ago, you know that we've gotten a lot better with helping you to move your data into AWS since that time. Now, the typical steps of building a data lake, you're going to think about first and foremost setting up your storage and then moving that data onto that storage. Next, you'd go through the process of cleansing, prepping, and cataloging that data. And then the whole point of building a data lake to begin with is actually to democratize your data for those business users. But you really want to be able to configure and enforce some security and compliance controls so that you know that your PII data is protected. And then, of course, you would make that data available for your business users to do analytics on top of. Now, when defining the AWS data lake, you want to think about your data lake as well as your data warehouse in which you might have other systems such as your ERP or CRM feeding into. And then, of course, on your data lake, you'd have data streaming in, but also coming from devices and other web locations. And then, of course, you would catalog that data and then make it available so that people can do data warehouse queries, big data processing with business intelligence, and then also making your users be able to do machine learning with that data. And of course, our data lakes, when you build your data lake on top of AWS, it's really designed for low-cost storage and analytics, and you can work on that data without having to move it around. And we offer a diverse set of tools for you to do analytics and machine learning on. And then, of course, you can scale out and have your data lake have both relational and non-relational data inside of it. So think about when you're doing work with your data. Of course, you're going to have user-defined functions. And you want to think about using Lambda in order to do that. With Lambda, you can bring your own functions and code, and then you can execute that without having to worry about provisioning servers. And then, of course, if you're used to doing ETL, think about using our services such as Glue, Athena, and Redshift, and SageMaker so that you can actually catalog and transform and query that data sitting in S3. And you really don't have to worry about managing your instances, patching them, worrying about when they fail, et cetera. So this is what we envision as the data lake on AWS, right? So it starts, of course, with S3 in the center. And then we have all of these different ways in which you can ingest that data, from Snowball to Kinesis to Direct Connect, as well as Storage Gateway and our database migration service. And then we have these other tools which you can catalog and search, such as Elasticsearch, DynamoDB, and of course AWS Glue. And then we provide ways for you to access it, and such as API Gateway and AppSync. And then, of course, managing and securing that data, the most important thing that you want to think about as well, with KMS, IAM, and CloudTrail and CloudWatch. And then we provide a myriad of ways for you to do analytics and then serving of this data to your business users so that they can get faster insights into your data lake. Now, on that last slide, we had a ton of services, right? But really, the modern serverless data lake has just 4 simple components, okay? S3, AWS Glue, Lambda, and CloudWatch events. So let's talk about those 4 components. So again, we really believe that S3 is the best place for data lakes. It has unmatched durability, availability, and scalability, and we have the best security and compliance and audit capabilities. We also have object-level controls so that you can have fine-grained access down to the object level inside of your data lake. And you can quickly build insight into that data by putting it on S3. And then, of course, there's the most ways to bring data in. So let's talk about bringing data into your data lake. So over the years, we've really increased the number of ingest methods that we have to bring data into S3. And you can bring in data of all types. So, if you're looking to bring in IoT or sensor data or clickstream data, think about using Kinesis Data Firehose. If you want to bring in relational data from your traditional RDBMS, think about using AWS DMS. Perhaps you have an on-premise ERP that is in a hybrid mode, and you really want to bring some of that data into AWS. Think about using Storage Gateway. Some other things are very difficult to sometimes be able to move that data in, such as lab equipment, controls, et cetera. Next, you can also use Snowball Edge to bring in offline sensor data, NAS data. And then if you're working, again, in a hybrid mode, you can use Direct Connect to bring in things from perhaps your on-premises data lake, or if you have an on-premises enterprise data warehouse. But if most of you are like me and you spent many years doing ETL, you know that FTP is actually at the core of many ETL processes. Before I came to AWS, I spent a couple of years working for e-commerce companies. And FTP was actually the lifeblood of what we did. We got catalog data from other vendors. We had to push information out through FTP. And so when we launched SFTP, I think I talked to one of the service team leads, and they were very surprised at how fast the adoption was of this product. But to me, it makes perfect sense, right? Because FTP servers can be difficult to manage. And if you use SFTP, it's a seamless migration of your existing workloads. It's fully managed, and secure and compliant, and very easy and cost-effective to use. And we also have a service called AWS Data Sync. I believe it launched about last year this time. And you want to think about this as like rsync on steroids. So if you have items in your on-premises data center that you need to be able to sync up to the cloud, you can deploy these agents very quickly. They will transfer up to 10 gigabytes per agent, and you can have simple movement into Amazon S3 or EFS. And again, these are secure and reliable transfers, and you don't have to worry about the underlying infrastructure, and you just simply pay as you go. So really, when you're moving data into your data lake, you will likely have many different formats of data, and there is no one perfect format for you to have all of your data in your data lake. All of them are going to have trade-offs, and it will really depend on the workload and tool. And I'm sure you've heard that a couple of different times here. Pick the right tool. So in many ways, CSV or tab-delimited JSON, they are easy to work with, but they may not be the most efficient. And they will compress and store this archive as raw inputs. So the other options are columnar compressed. These are usually preferred, but it's because it's a smaller storage footprint, and they're more efficient to scan and query. But again, this might not necessarily be the right thing for you. You can have row-oriented data, such as Avro, good for full data scans. And you can organize this data into partitions, and you can coalesce into larger partitions over time. So the key considerations for what format your data will be in are really cost, performance, and support. What can you actually fully support? So I'm going to turn it over right now to Srinivas, who's going to talk about serverless ETL using AWS Glue.
Thanks, Daniel. So you have seen how to get the data into Amazon S3 using various methods. And now I'll show you how to transform the data into the destination format using AWS Glue. So data preparation, the studies show that the preparation of data takes 80% of data lake work. As you see in the chart here, we are spending a lot of time in just collecting the data and preparing the data. Now, with the modern data workflows, you are getting the data from social media feeds, Twitter feeds, mobile devices. It's coming in wide variety of formats, and the scale of operation is increasing. How are you going to make it very cost effectively analyze this data? Maybe you can make use of some data wrangling tools, or if you have a team of data engineers that can write custom programs for you to prepare the data, that is one way to do that. But still, it is very complex, resource-intensive process. Even then, we may not have a data catalog ready for you, which is again another complex operation. So in a sense, we are looking for a tool that can do data cataloging and data transformation in a cost-effective and efficient manner. AWS Glue can help you in all these tasks. AWS Glue can automatically crawl your data sources in target systems such as Amazon Redshift, Amazon S3, Amazon RDS, or any other supported databases running on Amazon EC2 instances, and can create a data catalog for you. It is a serverless service, so you would pay for only when the Glue is running. And as you see in today's demo session, using Lambda and CloudWatch events, you can basically automate the entire ETL pipeline. So AWS Glue has 3 components. The first one is data catalog, the second is job ordering, and the third is job execution. So data cataloging is how do you catalog the data, and AWS Glue has mechanisms in place to crawl your data and prepare the catalog for you. And it is integrated with other services such as Amazon Athena, Amazon Redshift Spectrum, and Amazon EMR, and Hive Metastores. What it means that when you go to Athena console, you can basically see Glue data catalog right in the console and access the data directly from Athena. I'm going to show that in the demo how it works. And the second one is job ordering. How do you create a job? How do you write ETL code in Glue? Glue has automated way of generating ETL code, and it is very developer-centric. You can easily edit, debug, and share the code with others. Job execution happens in a serverless manner. You are not provisioning any servers for that, and it provides flexible scheduling and handles dependency resolution, monitoring, and alerting. So we look into Glue data catalog in little bit deeper. What it is Hive compatible catalog, but it means that it works with Hive, Presto, Spark. So if you go to a Presto config file, you can point to Glue data catalog and use that as a metastore. You can do the same thing for Spark. It supports all standard operations. You can search the catalog. It has the connection info, and it has the built-in classifiers. That data also, you can use it to parse the data files, and it has the capability to version your data catalog. As your data is changing in the source data, how do you basically make sure that it is the changes is happening? So it has a versioning capability to version your data catalog, and there are many ways to populate the data catalog. You can, if you have an existing Hive metastore running in your current environment, you can use our import script to import the data catalog into AWS Glue, or you can go to Glue console and create a custom Hive DDL and then run it. So interactively, you can build an ad hoc Glue data catalog, or Glue has a mechanism to automatically crawl your data sources using crawlers, and then build a catalog for you. So we'll see how the crawlers work. So when you go to Glue console, you'll see a crawler, and you define the crawler, and you point the crawler to your data source. So what crawler does is, it uses the built-in classifiers in AWS Glue and applies these classifiers on the source data, parses it, and builds a data catalog. AWS Glue out of box has many built-in classifiers. We have classifiers for traditional databases like Oracle, MySQL. We have classifiers for Redis log files, Linux kernel log files. So we have a whole set of built-in classifiers that is well documented in Glue documentation. But if your business needs evolve and you think the built-in classifiers are not meeting your requirements, you can go and customize and write your own classifier using grok expression. So a grok expression is nothing but a regular expression. So when you define your custom classifier in your crawler definition, you can basically define more than one classifier and assign a priority to that. So when the crawler runs, it picks the high priority classifier and runs against your source data, and it tries to see how well it can classify the source data. So when it thinks that the certainty level is pretty high, then it uses the classifier. If the certainty level is not that high, what it does is it goes to the next classifier in the list and runs it, and so on, till it finds the classifier that can classify your data with high certainty. So once the crawler runs and it classifies your data, the next step is you can schedule the crawler, or you can run an ad hoc basis. Since crawler is also serverless, you pay only when the crawler is running. So the crawler, when it runs for the second time, if it notices any changes in the source data, it can identify them. It identifies the new partitions in the source data and sync up with your existing data catalog, and it can version it as well. So how does crawler detects the partitions in the source data? So what it does is it does something called schema similarity. So you have, let's say, S3 bucket. It has 4 or 5 files in that. It goes to the first file. It finds all the partitions in that. Then it applies the schema similarity with the second file and see what are the partitions it has, and then so on until it reaches the root S3 bucket. And then it gets all the partitions and create a table. So as you see in this example, it found almost 99% similarity on date and month partitions. So it created a table with the date and month partitions. So once the partition is done, your catalog is ready. This is how it looks like in the Glue console. You have a table name and the statistics on the data, how many records are there on the source data, what is the average record size, as well as what kind of compression it uses, and then table schema, which is nothing but columns and data types. So once the crawler is done, the second step is how do we write code in AWS Glue. AWS Glue supports many ways to do this ETL code authoring. It can automatically generate using crawlers. So when it generates the code, you can go to Glue console and take a look at that one. If you're not comfortable right away modifying the code in the Glue console, it exposes an endpoint. You can define the development endpoint. And if you have already an IDE, you can connect that IDE to this dev endpoint and start working interactively with AWS Glue in your IDE. Or if you are a notebook person, you use Zeppelin notebook, you can connect your Zeppelin notebook to Glue development endpoint and interactively explore your data. And then once you are done with all the coding, you can upload this code into S3 bucket and then register an ETL job. That's as simple as that. Or if you think you already have an existing code running in your system, you can bring the same code into AWS Glue and start working on that one. So this is how it does automatic code generation. You have source schema. The source schema is done by the crawler. So once the crawler generates the source schema, what you do is you go and map it in the console through the destination schema. And it doesn't need to be one-to-one mapping. You can do your customization here. Once you are done with your mapping, in the next screen, it generates the code that you see on the right side. So the code, if you look into that, on the left side, whatever diagram is showing, it is auto-generated by Glue. Inside the code, you notice some annotations there that is used by AWS Glue to generate the diagram on the left side. The diagram gives you a high-level flow on what Glue is doing. In this example, it is taking the source data and applying 2 transformations and then writing to the sink. The code basically is very simple, easy to understand. You can either edit in your IDE or you can basically use a Zeppelin notebook. It's very easy to share with other developers as well. You can use GitHub and share it across many jobs also. So in the code, if you notice, the first step what it is doing is, it is getting a reference to a Glue contest, right? Once it got the reference to Glue context, the second thing it is doing is it's creating a dynamic data frame against your source data set. Then it applies the transformations. So I will walk you through what is the dynamic data frame in AWS Glue is. So AWS Glue, if you are familiar with the Spark architecture is RDD, you have data frame, then you have Spark SQL. In the Glue, you have RDD, Glue Dynamic Data Frame, and Glue ETL. So what the Spark data frame is, Spark data frame assumes you have a fixed, well-defined schema beforehand. Whereas in Glue Dynamic Data Frame, the schema is inferred on fly. So what it fetches you is in a semi-structured data set where you don't have fixed schema, when it reads the records, it can infer the schema and it can transform the data in one pass. That really saves you a lot of time because of this architecture. And if you look at this diagram here, that B1, B2, what it means that when it is basically, let's say you have an employee record, in the first row, you have an employee record with ID as string. In the second row, you have employee ID as int. So what dynamic data frame does is, it doesn't basically typecast one to other. It will give an option to you. It says ID has both string and int. Later, you can apply a transformation on that to either match transform string to int, or you can keep both of them in your system. So that kind of flexibility also it provides. So having said that, this is not as complex as you think it is. A lot of code is already generated by AWS Glue. We don't need to start from scratch. There are a lot of examples written in GitHub. You can use those examples as starting point to write your AWS own code if you would like to really customize the code. And we have migration scripts to migrate the data from a Hive compatible store into AWS Glue, or you could export the data from AWS Glue into a Hive compatible external store as well. And also, we have examples of dynamic frames, how to use it. And there is another nice transform called relationalize. What it does is, let's say you have a nested JSON data set, and you would like to flatten it, and then put it in a relational form and save it into a traditional database. So that transform can help you to basically flatten the entire nested JSON and then put it in a format that you can ingest into Amazon Redshift. So there are a lot of examples you can use. Python ETL library is out there. Having said that, the third step is how do you execute this job? So Glue, it supports many ways to execute your job. Either you can run an ad hoc basis, or you could use a typical cron tab kind of expressions to schedule your job. The third is you can trigger it from a Lambda function that I'm going to show you how to do that. Or you can based on some S3 notification, a triggering action in cloud event you can do, or based on a completion of another job, you can trigger any other job. So looking at that diagram, you can basically create a complex ETL pipeline using these triggering actions. And it runs in a serverless manner. That means we are not provisioning any servers to run any jobs. You can define at the time of job creation which VPC the job needs to run. So if you have two jobs running in the same account, if you say these two should be in different VPCs, these jobs would be run in isolation in a secure way. And you can define the capacity of the job at the design time. And finally, since it is a serverless application, when the job is running only, you are paying for the job. Let me quickly walk you through 3 customer use cases. The first one is log aggregation with AWS ETL, Glue ETL. Here what we are doing is we are getting log files from source systems, and agents are running on the source system to push the log files into Amazon S3 bucket. And a Glue ETL crawler will crawl the source data and catalog the schema. Once it is done, a ETL job will transform the source data into a destination format. And Athena, you can run a query in Athena to get insights from the destination system. This is the real-time data collection using Glue ETL. Real-time data, if you notice, you have a lot of small files coming in, and there is a pause, and then again there are small files. So AWS Glue is a perfect ETL engine for that kind of activity. So here what we are doing is we are basically getting all the real-time events into another service called Amazon Kinesis Firehose. So what it does is it has the capability to push the real-time events into Amazon S3 bucket. From there, a Glue crawler will run, catalog the data, and then ETL job will transform the data into a destination format, and you can query it from Amazon Athena. And the third use case is your typical traditional databases. You have a lot of databases running your on-prem systems. You can use JDBC connectors from AWS Glue console connecting to your source systems, and then you catalog the data. Either you can directly push it into one of the RDS or Amazon Redshift, or you can transform into your destination format that can be used by Amazon Athena. So with that, I'll hand over to Danielle, who can go through another serverless service, Lambda, which helps us to automate the entire pipeline.
Thanks. Thank you. Yeah, so let's dive in a little bit to Lambda, which is really one of the core components of this serverless data lake and the pure underpinnings of this automated processing. So of course, the benefits of Lambda, you have no infrastructure that you have to manage. All you really have to do is focus on your business logic. And it's really meant to be cost effective and efficient, and you really just pay for what you use. When Lambda launched several years ago, they were thinking of what was going to be the name of it, and I remember the GM telling me, well, think of Lambda as really just cloud functions. And that's all you really have to think about is what is going to be your function and what do you really want to do with the data, and that's it. And you can run your code in a list of standard languages and get started right away. So think of your Lambda function as having 3 core components, or rather your application components for this serverless application with 3 core components. So first and foremost, there is going to be your event source. So this is really what are you going to trigger on? And this could be a change in a data state, such as a record was inserted into a table. It could be an API was called, and it could be a change in a resource state. You can think about this for like AWS IoT for MQTT requests from devices, something like that. That could be a great Lambda event source. And then of course, next is your Lambda function, which is the code that you are going to execute. And then also the services are really anything that you are then going to do once that code is triggered, right? So Lambda can pretty much integrate with any AWS service, but you could actually also operate on things outside of AWS as well. As long as it has an endpoint, it's probably something you can work with. So here's some examples of some of the event sources that integrate with Lambda. S3, Dynamo, Kinesis, Cognito. We have RDS, Aurora is new. Oops, that went by too fast. And then some endpoints such as Alexa, API Gateway, IoT. And then repositories, event message services, and orchestration state management. And the list grows, so this is just kind of moving on its own. But think about this as a Lambda use case for streaming data ingestion. So a typical ETL process, you're going to have record producers out there, Kinesis possibly piping in streaming data, and piping in raw records into your Kinesis Firehose. And then when this happens, you're going to want to run your Lambda function. You might do some metadata processing with Dynamo, maybe some cataloging, and then you can then send those transformed records into S3 perhaps, or maybe you want to send it to Redshift or to Elasticsearch. And you might also want to be retaining some of your raw records in a backup as well. So here's a typical use case for Kinesis streams and Lambda. So again, think of your streaming source coming in that will trigger your Lambda function, and then you can then output to other AWS services. So, but you also want to consider that the number of Kinesis stream shards will correspond to the concurrent invocations of your Lambda functions. And batch sizes will set maximum numbers of records per Lambda function invocation. So there will be some tuning that you have to do in order to make this work effectively. Okay, I'm going to turn it back over to Srinivas to talk about serverless data lake architectures in depth here. Thank you.
So I'm going to show you a quick demo on how to connect all the dots. Now we have gone through AWS Lambda, we have gone through AWS Glue and Amazon S3. So we quickly build a pipeline using all these services, using all these three services. So this is how the architecture is. There is a blog post on that. The link to the blog post is in the slide deck. So what it is doing here is, basically we have source S3 bucket, Amazon S3, and then we have processed bucket, that's the destination, and a Glue is sitting in between that is doing all the transformation. And the other services that you see here, they are basically enablers. They are enabling us to build this pipeline. So let me basically walk you through the entire workflow. So a file will gets ingested into source S3 bucket. Once it falls into S3 bucket, an S3 event gets triggered, and that S3 event basically invokes a Lambda function. The Lambda function does two things. It has the logic to retry the SQS queue, and if there are any unprocessed records or that it has to reprocess, it does that. And the second one is, it basically kicks off Glue crawler job. So once the Glue crawler job finishes crawling the data source, it basically generates an event, a CloudWatch event. So in the CloudWatch event console, we have a rule. What it does is, when the crawler runs successfully, the event gets fired, and that event invokes a Lambda trigger. So this Lambda trigger has very simple logic. It does only one thing. It just triggers a Glue ETL job. So the Glue ETL job, once it gets completed, it writes the records to the processed bucket. And we have another event rule. What it does is, it generates the event also. So this event rule gets fired, and this event rule, it sends an email via SNS service to you that your data is ready for consumption. So the entire pipeline is automated. So we have a blog post on this one. So if you go to this blog post, we have a link to CloudWatch formation template. So when you click on this CloudWatch formation template, here you define a email. This is the email that SNS would use to send the notification to. And then you define a crawler, and then you define a database. Once you acknowledge that you are giving permissions for a cloud formation to create resources in your account, and once you click on this create stack, so I already created the stack. So these are the services it creates. Mainly it creates two S3 buckets. It creates two Lambda functions, and then it has many IAM roles, which is giving permission for these services to access S3 bucket and access each other. And it has SQS queue and SNS event. So let's see what the source S3 bucket has. This is my raw bucket. I basically uploaded two files in comma separated value format. So these files, there is a link from our blog post. You can use that link to download. New York green taxi data is a open source data you can use. So I downloaded those two onto my laptop and uploaded into S3 bucket. So when you upload the S3 bucket, in the bucket properties, you have events. So here I go, and I created an event. So what it does is, when there is an action, here I'm saying all object create events. So when I drop this file into S3 bucket, this event gets triggered, and I'm telling this event that once that action happens, send the notification to a Lambda function. So this Lambda function, this is already deployed in the cloud formation. It does two things. It does the retry logic in SQS service, and then it is basically invoking crawler. So once the crawler is there, if you see in the Glue console, this is how the crawler is. This is the data crawler. So this is how it gets generated by the triggering action. And this is the table it created after it ran the crawler job. So as you see here, you have table name, database name, and table properties, which has a number of records. You have almost 1 million records there. And what is the average record size? It basically identifies all those. And you can see the schema here. The schema means just a column and data types. So once the crawler is done, it generates a CloudWatch event rule. So we'll go to a CloudWatch event rule and see how it looks like. So whenever a Glue crawler and Glue job completes, every time a CloudWatch event gets generated and it generates an entry into the event, and this rule gets fired. And this rule does very simple action. It checks on the data crawler and the state is succeeded. When it meets that condition, what it does is it invokes a Lambda function, Glue blog ETL job. So this is the actual ETL job that gets kicked off by the Lambda function, and this is the job. This is something we have to, there is a clear instruction in the blog post how to create this blog. So if you look into this job script, it has very simple logic inside that. So this script basically, if you look at the transformations, it has the source data from raw S3 bucket, then it is applying 3 transformations: apply mapping, resolve choice, and drop null fields. So apply mapping means it is basically mapping the source to the destination schema. And resolve choice means when they have multiple data types mapped to a column, it is resolving it. And the third one is dropping the null fields from the source schema, and then it writing to the sink. So in this code, basically we didn't do any customizations. It's a simple one-to-one mapping. We're taking a comma-separated value file, and then we're transforming into a Parquet file format. So a whole code is generated by AWS Glue. So once it gets completed, another CloudWatch event rule gets fired. So this rule, what it does is once it checks on the Glue ETL job, once it knows that it succeeded, it generates an SNS event. So this SNS event sends an email to you that the job is completed. So let's look at the target S3 bucket. After it is done, this is how it looks like. You have data in Parquet file format. You have 2 records transformed from CSV to Parquet file. So once this data is here, we can go to Athena. Here what I have done is I want to show you both Athena and QuickSight. You can basically run a query in Athena and get the insights you are looking for. Or if you want to do a dashboarding thing, you can use our another service called QuickSight, which basically graphically visualize the same thing. So in order to do that, I have created an external table pointing to the data source. Since it is integrated with Glue data catalog, I can see all my catalog here, and I can use that table and create an external table. So once I'm done with external table in Athena, I'm going to QuickSight. In QuickSight, when you define a data source, you can define Athena as your data source, and then you can see all the tables you created in Athena. So using that, this is just, if you would like to add another visualization, you can basically add it here. And then you can use your x-axis and y-axis and see what kind of analysis you would like to see. So once this is done, your entire pipeline is automated. So from end to end, it is done. And if you have a new file coming into S3 bucket, it automatically gets refreshed, and you get an email sent, and then your QuickSight will automatically get refreshed by the source data. So using this, the whole thing, what we achieved here is we converted a CSV file format into a Parquet file format, and then we are pushing the data into Athena and QuickSight for further analysis. So with that, I turn over to Danielle to walk us over our ecosystem.
Yeah, so just to wrap up, the steps that Srinivas went through, steps in building this serverless data lake. You're going to ingest your data into S3, configure that trigger that you want to generate your pipeline, and then automate the data catalog with AWS Glue Crawler. Author your ETL jobs, automate that ETL job execution, and then monitor the success with your CloudWatch events, okay? So data lakes and analytics. Obviously, we feel here that there are more than 10,000 customers that are running data lakes on top of AWS, and you can see some of the logos here on this screen. And then we have a wealth of partners that can help you to build your data lakes on AWS and also help you govern them, secure them, and help you do, if you don't want to use Glue, we also have Talend, Matillion, lots of other great partners that can help you to do ETL on AWS, as you can see from this slide here. And then this here is the link for the blog post that Srinivas was pointing to that actually has all of the CloudFormation templates, the architecture diagrams, and some instructions for you to walk through. If you want to build your own serverless pipeline inside of your data lake so that you can do this on your own after this session. There are some related breakout sessions that might be of interest to you if this is a session that you came to. We have sessions on S3 to Lambda, a flexible pattern and at the core of serverless applications, some sessions on ETL with Apache Spark and Python, serverless big data processing, and managing events in your serverless application, as well as a serverless journey with Lambda. So we'd like to remind you, if you don't mind, we'd really love for you to give us some feedback on this session. Let us know what you think. We really appreciate you coming today. And so we have about 15 minutes left before they're going to be turning this room over to the next session. So if you have any questions for us, we'll be up here in the corner and we can answer those questions for you. But please give us some feedback on this session. Thank you.